This is Activity 2, Matching Equation Moves from Lesson 3, Balanced Moves, and Unit 4, Linear Equations and Linear Systems. And this is a revised version of Activity 2. In this activity, you are to match each pair of equations. There are 5 pairs, plus there's one more that you have to make up on your own, to its corresponding move that takes you from the first equation to the second equation. Here are the moves. There are 3 operations that use multiplication and 3 operations that use addition. And so notice, if you are multiplying each side by negative 1/3, more than likely you are getting rid of a negative 3 as a coefficient. If you're adding a negative 3x to each side, you're getting rid of a positive 3x as a whole term. If you're adding 3x to each side, you're getting rid of a negative 3x as a term. Add negative 3 to each side, you're getting rid of 3 as a constant. And if you multiply each side by 1/3, you're getting rid of 3 as a coefficient. So you're making that 1. And if you're multiplying each side by negative 3, you're probably getting rid of a negative 1/3 as a coefficient. So you're making that coefficient 1. So look for those as we go through each problem. Here are each of the equations and the first step. So multiply each side by negative 1/3. So this is move A. So which one of these does that match? So you're probably getting rid of a negative 3. Look at each one of these rather quickly. So a negative 1/3 times 3 does not give you 7. 12x times a positive 1/3 equals 4x. But this is negative 1/3, so that doesn't work. 10 times negative 1/3 does not give you 7. 5x over negative 3 times negative 3 equals 5x. But again, this is negative 1/3. So the last possibility, 5, is the answer actually. So negative 3 times a negative 1/3, this becomes 1, so it gets rid of this negative 3 as a factor. So you're left with 4x minus 3, and 15 times a negative 1/3 equals 5. So A matches 5. Add negative 3x to each side. And the first one is the answer. So 3x plus a negative 3x gets rid of this term. You are left with 7. And 5x plus a negative 3x equals 2x. If you quickly look at the rest of them, 12x plus a negative 3x does not equal 4x. 5x plus a negative 3x does not equal 5x. This doesn't work, and this one doesn't work. So B matches 1. So C, add 3x to each side. This one doesn't match any of the given equations, so you have to make up your own equations. I'm going to come back to this a bit later. Add negative 3 to each side. This is D, and the answer is 3. So if I add negative 3 to 10, that equals 7, and add negative 3 to 4, that equals 1. So you're removing 3 units from each side. Doesn't work for 1, doesn't work for 2. 6 plus negative 3 equals 3, not 2. Doesn't work for 4, does not work for 5. So D matches 3. So D matches 3 here. Multiply each side by 1/3. This is E. So you're going to get rid of the coefficient of 3. So this would become x, not 7. 12x times 1/3 is equal to 4x. 3 times 1/3 is equal to 1. And 6 times 1/3 is equal to 2. So number 2 is the answer. And notice you have to test it for each term. So the 12x, the 3, and the 6. So 10 times 1/3 does not equal 7. 5x over a negative 3 times 1/3, that one doesn't work. A negative 3 times 1/3 is negative 1, not positive 1. And a negative 15 times 1/3 is a negative 5, not positive 5. So E matches 2. E matches 2. F, multiply each side by negative 3. 3x times negative 3 would be a negative 9x. 12x times negative 3 would be a negative 36x. 10 times negative 3 would be negative 30. But 5x over negative 3 times negative 3. So if you're multiplying by negative 3, you're probably removing a negative 1/3 as a fraction, and that's what you're doing. A negative 3 times a negative 1/3 is equal to 1. So you're left with 5x, and 12 times negative 3 equals negative 36. So 4 works. and 5 does not work. A negative 3 times a negative 3, this would give you a positive 9 times 4x minus 3. So that does not work. So F matches 4. F matches 4. And C, add 3x to each side. And that doesn't match any of the 5 given pairs of equations. So you have to make up your own. So I'm going to add 3x to each side. So I have to come up with something to add 3x to. So I'm just going to make something up. I'm going to put a 2x here, so 2x plus 3x. This side is going to become 5x. I'm going to put a negative 3x here, so I'm using this 3x that I'm adding to get rid of this negative 3x. I'm just adding a constant term here, 5, and I decided to add another constant term on this side of negative 8. So just making stuff up. So 2x plus 3x equals 5x, still adding a negative 8, and getting rid of this negative 3x. So that equals 5. So C will match 6. C will match 6. I made up my own pair of equations where I added 3x to go from this first equation to this second equation. But what if we were told to use one of the previous 5 equations and add 3x to both sides to get a second equation? So I'm going to do that with 4 and with 5. So I'm going to add 3x to both sides for 4, and I'm going to add 3x to both sides for 5 to see what I would get for that second equation. So remember, for 4 to get to the second equation, you multiplied by negative 3, and for 5 to get to the second equation, you multiplied by negative 1/3. But I'm going to change those. I'm going to add 3x to both of these, both sides, to see what I get as that second equation. So the idea behind this activity is to keep both sides of an equation balanced by doing the same operation on both sides. So if I start out with equation 4, and this is equation 5, if I add 3x to both sides, and on this side I'm going to change subtracting a positive 3 to adding a negative 3, just makes the calculations a lot easier. So I always change, maybe not always, but as much as I can, I change subtraction to addition by adding its additive inverse. So this one's not too bad. So negative 3 times what's inside parentheses plus 3x equals a negative 15 plus 3x. So far so good. But on this side, if I'm going to add 3x to this term, I have to have a common denominator. So I have to rewrite 3x as negative thirds. The way to do that is to multiply by negative 3 over negative 3. So that's equal to 1, so I'm not changing the value at all. I'm just multiplying by 1, adding 3x right here. This becomes a negative 9x. Negative 3 times 3x is a negative 9x, and this is over a negative 3. So these two terms now have the same denominator, so I can add them together. Here's the 12 plus 3x, and on this side, I use the distributive property, so this is a negative 3 times 4x plus a negative 3 times negative 3. Over here is a negative 15 plus this 3x. So just continuing, so I'm just taking care to do the same operation to both sides of the equation. So now I can add these numerators together, so negative 9x plus 5x, negative 9x plus 5x. And on this side, this has now become a negative 12x. So negative 3 times 4x is a negative 12x plus a positive 9. Negative 3 times negative 3 is a positive 9 plus 3x. And on this side, it's the same. And so the last step is negative 9x plus 5x is a negative 4x. And on this side, there's no change, so it's 12 plus 3x. And this is a negative 4x over negative 3. So we could change this to 4x over a positive 3, because a negative 1 divided by a negative 1 is a positive 1. So we could go one step farther. This is a negative 9x plus 9. So this is negative 12x plus 3x. Negative 9x plus 9 equals a negative 15 plus 3x. So for both of these, if you're given the operation of adding 3x, both of these would be an answer to that operation. So now that I've worked with this equation and gotten this equation down here by adding 3x to both sides, what that means is if I add 3x to 5x over a negative 3, if I add 3x to that, it should equal a negative 4x over negative 3. So I want to work with just this left side for a moment, where I add 3x to this left side, and I should get this left side down here. The right side's easy. 12 plus 3x is 12 plus 3x. But this looks different. So I want to prove that this does, in fact, equal 5x over negative 3 plus 3x. So now I want to prove that 5x over negative 3 plus 3x does, in fact, equal a negative 4x over negative 3. I'm going to prove that by taking this 3x away from the negative 4x over negative 3. So negative 4x over negative 3, I'm going to take that 3x away. So I'm going to add a negative 3x. And I'm going to change this to 4/3 x. So negative 1 divided by negative 1 is 1. So that's 4/3. You're left with 4/3 x. So I'm going to add a negative 3x. I'm going to subtract 3x from this term. So adding a negative 3x. I'm going to rewrite 4/3 x as 1, which is 3/3 x, plus 1/3 x, and plus a negative 3x. The reason I'm doing that is now I can combine this negative 3x plus these 3/3 x, which is 1x, and that added together equals a negative 2x. Left with this 1/3 x right here. Well, 1/3 x plus a negative 2x, so it's 1/3 less than 2. So 1/3 less than 2 is 1 2/3, but it's negative. So this is a negative 1 2/3 x. Negative 1 2/3 x is the same as a negative 5/3 x. And this negative can be one of three things. It can be a negative 5/3, and it can be a negative 5 over 3, or it can be 5 over negative 3. So it takes a while to get used to that. We're not going to go through why that works right now, but you can move that negative sign around because you're multiplying by negative 1. And this 5 times x becomes 5x. So I'm going to move that negative down here. So this is 5x over negative 3, which is where we started. 5x over negative 3. So I'm really out of control on this, but let's complete the whole picture. So let's go back to the original first equation and solve for x. So 5x over negative 3 equals 12. So 5x equals negative 36. I'm going to multiply through by negative 3. So 5x equals negative 36. X is equal to negative 36 fifths, which is the same as a negative 7 1/5. So that's the value of x. So if I now replace up here, if I replace x with a negative 7 1/5 times 5, this is a negative 36 fifths times 5 over negative 3. This 5 times 5 is equal to 1. So you get a negative 36 over negative 3. That's equal to 36/3, which does in fact equal 12. So up here then, if I replace x with a negative 7 1/5, that does equal 12.